So our topic today is on Surds. So my topic today is on Surds, and we are going to start with rationalizing the denominator. Rationalizing the denominator. So write the following. Rationalizing the denominator is the process. Rationalizing the denominator is the process of expressing. It's the process of expressing a fraction, having a surd in the denominator, having a surd in the denominator in such a way that there is no such a surd. In such a way that there is no such a surd. So that is basically rationalizing the denominator. So this is very, very crucial. Example, rationalize the denominator. Rationalize the denominator. Rationalize the denominator. Part A, we have 1 over square root of 18. 1 over square root of 18. If you look at it very, very keen there, you realize that square root of 18 is not simplified. So the first thing is to simplify square root of 18. How do you do this? You will say this is 1 over square root of, you go for 18 and ask yourself, which is the largest divisor, which is a perfect square? The largest divisor of 18, which is a perfect square, and that is 9. So this is 9 times 2. And then, what is the square root of 9? The square root of 9 is 3. And then here you remain with 2, square root of 2. So, square root of 9 is 3, and then we remain with square root of 2. So that square root of 2 is a surd because we don't have exact roots. So a surd is an expression which do not have exact root. So root square root of 2, it is not exact, and it is called a surd. So when we are rationalizing the denominator, we want to express it in a form that there is no such a surd in the denominator. So if you don't want a surd in the denominator, what we do, we will take 1 over 3 square root of 2, we will multiply by square root of 2 to remove that surd in the denominator, and whatever you do to the denominator, you also do it to the numerator. And this gives me square root of 2 over 3 times square root of 2 times square root of 2, it's like 3 times 2, which is 6. So the answer is square root of 2 over 6. We move to part B. Maybe I'm given something like 3 over square root of 12. 3 over square root of 12. Again, if you look at the square root of 12, it's not simplified. So the good thing is to simplify fast. So this comes to 3 over the largest divisor, which is a perfect square there, is 4. So this is square root of 4 times 3. And this comes to 3 over square root of 4 is 2. And then we remain square root of 3 there. So we are going to rationalize. So we'll have 3 over 2 square root of 3. We will multiply the numerator and the denominator by square root of 3. Because we don't want a surd in the denominator. And that is the process of rationalization. So 3 times square root of 3 is 3 square root of 3 over 2 times square root of 3 times square root of 3 is 6. Now, we cannot leave our answer like that. We cannot leave our answer like that. Take note that the 3 and the 6 we can simplify. So, by 3, 1, by 3, 2. And the answer is square root of 3 over 2. So let us pause a minute and then ask ourselves whether we are getting the first two, the basic ones. Now write the following. If the product of two surds, give a rational number, if the products of two surds give a rational number, then the surds are called conjugates. They are called conjugates. They are called conjugates of each other. They are called conjugates of each other. E.g., the conjugate of 3 plus square root of 2 is 3 minus square root of 2. The conjugate of 3 plus square root of 2 is 3 minus square root of 2. The conjugate of square root of 5 minus square root of 3 is square root of 5 plus square root of 3. So when I'm talking about conjugate, means the sign we change plus to minus and then minus to plus and the rest remain the same. So that is how we get the conjugate of one value. Then we move to example 2. Rationalize the denominator. Rationalize the denominator. Part A, we have 2 square root of 3 over 7 minus square root of 5. Two square root of 3 over 7 minus square root of 5. So this what you do, you have 2 square root of 3 over 7 minus square root of 5. And we say when we are rationalizing the denominator, we ensure that there is no such a surd in the denominator. So what we do is in the denominator, because I have a mixed surd, we will multiply by its conjugate. And the conjugate of 7 minus square root of 5 is 7 plus square root of 5. And then whatever you do to the denominator, you do it to the numerator. This will give me 14 square root of 3 plus 2 square root of 15. In the denominator, you recall that A plus B into A minus B is A squared minus B squared. So that is what we are going to be having all the time in the denominator. A squared minus B squared. So this one will be 7 squared minus square root of 5 squared. And this comes to 14 square root of 3 plus 2 square root of 15 over, this is 49 minus 5, which is 44. So just check it properly, over 44. So I'm saying at this juncture, it is very bad to leave your answer like that. You'll even feel there's something wrong somewhere. So you can simplify wherever possible. Like this one, you can simplify and divide it throughout by 2. If I divide by 2 throughout, I'll get 7 square root of 3 plus square root of 15 over 22. If you leave your answer at this point, you will lose a mark. So that is it. So you write very fast. We move to part B. 3 square root of 2 minus square root of 3 over 2 square root of 3 minus square root of 2. So in that case, what do we have? We'll be having 3 square root of 2 minus square root of 3 over 2 square root of 3 minus square root of 2. We multiply the denominator with the conjugate. So if it has minus, we put plus. And then the numerator, you also do the same. So here, it calls for keenness. It calls for keenness. Let us be very keen, because this is where students go wrong. So this is 3 square root of 2 into bracket 2 square root of 3 plus square root of 2 minus square root of 3 into 2 square root of 3 plus square root of 2. So what we do is we do it the way we expand quadratic expressions. So we just have this one multiplied by this and then minus. So we say that a plus b into a minus b is a squared minus b squared. So a squared minus b squared. So this what we do, we'll be having 2 square root of 3 squared minus square root of 2 squared, like that. So from there, now we work it out. Let me just write up here so that you can see. Now, this one is 6. 3 times 2 is 6, and then this is square root of 6. So it will be 6 square root of 6 plus 3 square root of 2 times 2. Then that gives me 3 times 2, which is 6. And then minus, this is 2 times 3 is 6. And then minus and plus is minus. And then this is square root of 6. So be very keen there because some students will write plus here. But because there is a minus, it will affect what is inside the bracket. Over, this is, if you do this one, you can even use a calculator. You will get it is 12 minus 2, which is 10. And then this comes to 5, because this is like saying 6x minus x is 5x. So this is 5 square root of 6 over 10. Remember, 6 minus 6 is 0. And then you divide by 5, 1 by 5, 2, and the answer is square root of 6 over 2. And that is the answer. So take note of that. Example 3. Example 3. Yes, Paul Alvin. Paul Alvin? Paul Alvin, you have an issue?
I have an issue.
Yes.
There where we divided where the first one there 6 into square root 6 plus 6 minus 6, then minus square root 6 divided by 10. How did you get 5 into square root 6 over 10?
5 square root of 6. Yes? A good question. So what I'm saying is 6 square root of 6 minus square root of 6, it's like saying 6x minus x. And 6x minus x is 5x. And that's why 6 square root of 6 minus square root of 6 is 5 square root of 6. Are we together, Alvin? Are we together, Alvin?
Yeah.
And then the 6 minus 6 goes to 0. So is that clear? Is that clear?
Yes, it's clear.
Yeah. So 5 square root of 6 over 10. And then I'll simplify and say by 5 1 by 5 2. By 5 1 by 5 2, and then I get square root of 6 over 2. So it's good you ask a question. Then the other one is simplify the expression. Simplify the expression square root of 48 over square root of 5 plus square root of 3. Simplify the expression square root of 48 over square root of 5 plus square root of 3, leaving your answer in the form, a square root of b plus c a square root of b plus c, where a, b, and c are integers. Where a, b, and c are integers. So if I look at this question, I need to sort out something first. You realize that the numerator is not simplified. So simplify that. So what we do is we ask ourselves, what is the largest divisor? What is the largest divisor of 48, which is a perfect square? And it is 16. So you write square root of 16, then times 3. Because 16 times 3 gives me 48. Then over square root of 5 plus square root of 3. So simplify first before you rationalize. Then this one, square root of 16 is 4. And then the square root of 3 remains like that. Then over square root of 5 plus square root of 3. Then after that, we rationalize the denominator by multiplying by its conjugate. So this is the square root of 5 minus square root of 3. And this is square root of 5 minus square root of 3. So this comes to 4 square root of 15. Then minus. So 4 times 3 is 12 over. This one is square root of 5 squared minus square root of 3 squared. So this is 4 square root of 15 minus 12 over 5 minus 3, which is 2. And our answer will be, our answer becomes 2 square root of 15 minus 6. 2 square root of 15 minus 6. So that becomes our final answer. So it is actually in the form a square root of b plus c. And you can see very well that a there is 12, is 2, b is 15, and c is -6, of which the 3 are integers. So we have expressed it in the right form. So remember, the surd must be simplified. If I look at square root of 15, it is simplified. It is simplified. Another one, so also write that if there is a question you ask. So simplify 4 over square root of 5 plus square root of 2 minus 3 over square root of 5 minus square root of 2. Again, we call for keenness when you are doing this question. So this one you can see that these denominators are actually conjugates of each other. So what do? We simply multiply the 2. So this is then we ask ourselves, this divide by square root of 5 plus square root of 2 becomes square root of 5 minus square root of 2, and then you multiply by 4. And then this one divided by this is square root of 5 plus square root of 2. So this is square root of 5 plus square root of 2. So let us be very keen here. Let us open the bracket. This is 4 square root of 5 minus 4 square root of 2. Then minus 3 square root of 5. Then what else? Minus 3 square root of 2. Why? Because here you will see a student who has not gone to school properly, because minus and plus comes to minus. So you have to put minus there. So students will make a mistake there. Over square root of 5 squared minus square root of 2 squared. Because a plus b into a minus b is a squared minus b squared. So if you look at 4x minus 3x is x. So 4 root 5 minus 3 root 5 is root 5. Minus. And then minus 4x minus 3x is minus 7x. So this is minus 7 square root of 2 and then over what? 5 minus 2 is 3. This one is simplified. This one is simplified. Next one. Simplify 3 over square root of 5 minus 2 plus 1 over square root of 5. Simplify 3 over square root of 5 minus 2 plus 1 over square root of 5, leaving the answer in the form, a plus b square root of c, leaving the answer in the form a plus b square root of c, where a, b, and c are rational numbers. Where a, b, and c are rational numbers. So what you do, you first of all work out 3 over square root of 5 minus 2. So this is 3 over square root of 5 minus 2. You multiply with square root of 5 plus 2. And you do that in the numerator and the denominator. And then this becomes 3 square root of 5 plus 6 over square root of 5 squared minus 2 squared. And remember, this one will be over 1. So this is 3 root 5 plus 6 over 1, which is 3 square root of 5 plus 6. We are not yet through. This is just the first one. And then we move to 1 over square root of 5. Next, we move to 1 over square root of 5. 1 over square root of 5. You take 1 over square root of 5, you multiply by square root of 5 over square root of 5, which is square root of 5 over 5. Remember, there is no such a surd in the denominator. So from there, we add the 2. We take 3 square root of 5 plus 6 plus square root of 5 over 5. What do you get? What do you get if I want to express my answer in the form a plus b square root of 6? So I'll start with a constant, a. So the a is 6. So it will be 6 plus. So the question will be, what is 3x plus 1 over 5x? 3x plus 1 over 5x is 3 and 1 over 5x. And for information, 3 and 1 over 5 is actually 3.2. So it is 3.2 square root of 5. And that is the final answer. 6 plus 3.2 square root of 5. Another question. Express in surd form express in third form, and simplify by rationalizing the denominator. Express in third form and simplify by rationalizing the denominator. One plus cos 30 over 1 minus tan 16. Now, look at it this way. You have to know that 30 degrees, 60 degrees, and 45 degrees are special angles of which you can get their value. So like 30 and 60, you'll use equilateral triangle. So if I use equilateral triangle like this, measuring 2 centimeter, 2 units, and this is 1, 1, then the hypotenuse here will, this height here will be square root of 3. And this one, remember, is 60, and this is 30. So I say from there that cos 30, remember, you use the abbreviation SOH, CAH, TOA. So the cos is adjacent over hypotenuse. So adjacent there is square root of 3, and the hypotenuse is 2. And then the tan 60 is opposite of adjacent, which is square root of 3. So from there, you put it down there. You have 1 plus square root of 3 over 2 over 1 minus square root of 3. Then you rationalize the denominator by multiplying by its conjugate. Like that. Then from there, this is 1 into 1 plus square root of 3 plus square root of 3 over 2 into 1 plus square root of 3 over 1 squared minus square root of 3 squared. So we are almost clearing. And then here we have 1 plus square root of 3 plus square root of 3 over 2 plus, this is 3 over 2 over 1 minus 3 is negative 2. Now this comes to 1 plus 3 over 2, 2 over 2 plus 3 over 2 is 5 over 2. So 5 over 2 plus, so this is 3 square root of 3 over 2.